Hello everyone, my name is Shangguan from Amsterdam, France. The research presented today was conducted in collaboration with Meng Yongding, Chang Yu, and Chao Na Chen, under the guidance of Professor Adriana Buse. The title of our paper is Robot Self-Recognition via Facial Expression Sensory Remote Learning. Previous research has pointed out that chimpanzees can be aware of themselves in the mirror and pass the mirror test. Many research support that sensory motor is the key to achieve self-recognition. Sensory motor refers to one kind of human cognitive learning pattern through which a person learns the correlation between action, the effect of action, and the sensory signals. This phenomenon usually occurs in infants when they start to toddle. For instance, babies tend to frequently touch their rostral parts of the body in order to produce interaction between multiple subsystems. What we are interested in is that how can robot recognize itself in the mirror? We proposed a novel approach to achieve self-recognition via self-perception of facial expressions. In this work, passing the observed visual variation in the mirror and comparing them to self-perceptive information, the robot can recognize the self through an online Bayesian learning system. Specifically, we developed a conditional generative adversary network model using the knowledge on human cognitive and sensory motor functions that allows the robot to be aware of self-face. We first observe the variation of images in the robot wheel, and the variations of images are environment visual cues. Secondly, we use our self-modeling method to generate images of robot face. The variation of self-modeling images are self-reflection cues. Self-modeling images are generated by the sensory motor learning model. Thirdly, the robot keeps change its facial expression and tries to infer a prediction model from self-reflection cues distribution to an environment visual cues and tries to decrease the estimation error. Finally, after several iterations, the robot updates its inference model and gives confidence of whether an image is its face. In other words, the visual variations are caused by my face expression variations, so that's me. Our experiment robot is a humanoid robot called Zeno. Its face is equipped with 6 motors to control the shape of the facial skins and facial expression of Zeno. However, Zeno doesn't know its facial expression. What it knows are the parameters of the 6 motors. What we want to do is generate facial images from these 6 motor parameters. To achieve our learning model, we built up a dataset, a script capable of changing the different facial expressions of the robot by changing the 6 parameters of the motor angle inside the robot's head was developed. We recorded the 6 motors angle parameters and the robot face images of different facial expressions. The dataset is composed of more than 200,000 images, and each image matches 6 motors parameter inside the robot's head. We used the conditional GAN model to train the data and achieved our self-modeling algorithm. In this way, we can generate images with motor parameters. In the first experiment, the robot is positioned in front of a mirror and the visual sensor is fixed on the robot's head to observe information in its field of view. The robot presents several different facial expressions of recognition.
It's me. My confidence is 99%.
In the second experiment, the
Let's see who's
robot
in.
will see a similar robot that shows the same expressions in its field of view. In this experiment, we aim to test whether the robot will give a visual illusion result that it itself.
It's me. My confidence is 98%.
In both experiments, 15 random expressions are given, and the robot recognizes itself successfully. In our experiment, no arm or facial recognition method are used. No prior information about the environment is learned in advance. We use the offline sensor motor learning to generate real-time face appearance, online inference to learn the difference between the real world and estimation. The face of robot was detected and extracted to compare with each other by the Python program. Finally, the robot learns the real-world expressions variation within 15 iterations with more than 98% confidence. Also, the robot is tricked by what that looks like it and shows the same facial expressions, which means that the visual illusion also appears in our robot. Thanks for your attention.